Okay, so this is the second part of this video looking at, what is it going to take to graph an inequality. So remember the big idea that you start with. First, we got to graph the line, which is really more like a boundary. And then we look at the test point, test, and shading. So that's kind of where we're going with each of these. So let's start with the top, graphing the line. So it says y is less than 0. Okay, now it's already just getting weird on us because where did the x go? Well, with y is less than 0, y represents these vertical values. It really doesn't have an x in this relationship, which means x equals anything. Anything you want. But y has to be less than 0. So that means that we're going to have a line at y and 0, a boundary at y and 0. That means that I have a boundary right through the middle. Let's use a different color here to kind of really show that. We'll make it red. Cool. So I'm going to have this line right through there. And how do I know if it's dotted or solid? Well, I don't know. So let's take that back here for a second. So we know we're going to go across this middle. And let's check if we're dotted or solid. I see that this is not equal. It's not equal, which means it's going to be dotted. So I was right in doing the dotted line first, but it's good to check. Always good to check. So there's my dotted line going across the middle. Now the next thing that I want to do is check testing and then shading. So I need to test a point. I wanted to test right here 0, 0 in the middle, but that's not going to work. So I got to test something else. Let's try, I don't know, let's try down here, -1. So that would mean that y equals -1 and x equals 0. But remember, x can equal anything because it's not even in here, so that doesn't matter. But this part is important, the y equals -1. So let's plug that in. We start with y is less than 0, but we're saying y equals -1. So -1 is less than 0, and that rings true. That is super true. So that means that this side is true, which would imply to us, we could infer that the other side is false. So that means the true side gets the shading. Cool. Awesome. That one was really fast. Let's do another one just as fast. Let's pick a new color. How about purple? All right, so for purple, what I'm looking at, number 4 here, I see a relationship. I see a slope and a y-intercept. So it's got that slope-intercept format. Let's work with it. We have 2/3 x and then the -2. So -2 represents the y-intercept. That'll be right there. The slope in this case is 2 for the numerator, 3 for the denominator. So that means I'm going to go up 2 and then right 3 because those are both positive. So we got up 2 and then right 3. That puts us here. I can repeat that pattern and make kind of a dotted path to follow for the graph. And now let's take a look at the boundary line. I see not equal to. It's not equal. So that means we're going to go for a dotted line. I'm going to keep with this purple theme. And are we dotted or solid? I didn't even take a peek at that. It looks like we are dotted. Good. So I'm going to make a dotted line. And there's my dotted line. Perfect. Now what's next in the whole thing? We need to shade. So to shade, we got to test something. So let's pick a point to test. How about 0, 0? Why? Because it's easy. When you plug in zeros to an equation, the calculations tend to be very simple. So that means to start with, I'd have y is greater than 2/3 x minus 2. But I'm going to plug in 0 for my y and 0 for my x. So 0 is greater than 2/3 times 0 and then a -2. That means 0 is greater than 2/3 times 0 is 0. Then the -2 is still there. And this is true. This is very true, actually. 0 is greater than -2, which means this side with that little test point was true, which means the other side was false. So I'm going to shade the true side. There you go. Awesome. Okay, I'm actually going to scroll down here. We're going to work our way all the way to 6, and then the part 3 video will wrap up the rest of these. So let's scroll down a little bit. Okay, number 5 and 6. Now on 5, again, we have one of these weird things. And this one, it shows x is greater than 4, but there's no y in there. So it's just the x. So that means y equals anything. But our x values are locked in right at 4 for the boundary line. So that means I'm going to go to 4. I'm going to mark some points across, well, up and down the line for 4. So there's my boundary that I'm looking at. Okay, so using these points as a guide, I can make a boundary line. Let's see if this boundary line is solid or dotted. Looks like it is not equal, so therefore it's dotted. So I'm going to have a dotted line going straight through here. I'm just drawing a freehand. Should be done pretty quick. There we go. So I have a dotted line. Now it says x is greater than 4. Now I think I know which side that is on, but I'm going to go ahead and do a test point just to double check. So I'm going to choose 0, 0 for my test point. That's this point right there. And that means x is 0, y is 0. But y could be anything, so I don't really care about that. I really just care about this first 0. So let's see, 0 is greater than 4, if I were to plug that in. And that is false, people. Or at least you should think so. 0 is never larger value than 4. 4 is larger than 0. It's backwards. So this side is false, which means the other side is true. So this little skinny right side here gets all the shading. So jealous. The other side is so jealous. All right, last one for this little video here. Let's go ahead and wrap it up. New color. Let's get something fresh in here. How about orange? That'll work. Y is greater than x minus 3. Now this has a 1 over 1 in front of the x, so that's going to help us a little bit with the slope. And this negative 3 is going to help us with our y-intercept. So that means the y-intercept is at negative 3, so I'm going to go down to that. The slope is 1 over 1, so I'm going to rise 1, run over. So we got these dotted lines. And then we also know that this symbol is not equal, which means it's a dotted line. It's not going to include that boundary. So I'm going to make a little line here. We'll keep it orange. And let's go straight through all that stuff. There's a black shadow underneath it as well, but just to help it stand out. Now we just need to shade. Okay, so for shading, we got to test. Let's test 0, 0, just like normal. Why? Because it's easy to multiply. There it is right in the middle. So if I'm testing 0, 0, that means x equals 0 and y equals 0. So I start with y equals x minus 3, and if I plug in 0 is greater than 0 minus 3, so there's my x and my y coordinate, plugging it in, I would get 0 is greater than negative 3, which is true. That's actually true. We've hit a couple of true here. It seemed like we weren't hitting any true to start. So that's true. So I'm going to shade the true side because the other side is false. There we go. True, 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 true. True, 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 true. And that's it. Remember, again, watch these videos if you need more than one time. It's also going to be on YouTube, and if you haven't already seen from the notes, it's on the channel. You just go to youtube.com/user, and then the custom URL I put in here was PVHS Butler. There you go. All right, so that's that. We'll see you in the next video.